Hi, so I hope you're doing well. So this is just a recap of what we've covered over the last couple of lessons over the last week, and we were talking about applications and we were talking about the purpose and the different situations in which we might use them in. So I'm just going to continue, and our objective of these last couple of lessons is that you've been able to explain why we use applications in certain ways, and I wanted you to be able to actually think about why they were developed and what their purpose is. So we were looking at the nature of the application, and we were also looking at utilities. So we were looking at utilities such as compression, we were looking at file management, we were also looking at a disk defragger, and you were talking about how you might not use them in certain situations. We've also looked at open and closed software and talked about the differences. And in our previous lesson, we talked about how code is compiled so that you kind of had a better understanding of why we use compilers and assemblers in this. Now, there are three general categories that software is fitted into. And the ones that we've been looking at are utilities, application, and system software. So if you remember, utility software is software that only has one purpose, and it's generally there to actually help you maintain your computer and actually make it work a lot better. And if you remember rightly, application software is software that we use generally to produce something on a day-to-day basis. So we would use this particularly for things like Microsoft Word, we might use Microsoft PowerPoint. They are there for one purpose and generally are used for day-to-day things and help us produce something. And then we've obviously got our system software, such as our operating system, jobs that allow us to actually use the computer system. So previously we talked about applications and we talked about things that are available to us such as word processors, desktop publishers. We also talked about spreadsheets, database management, slideshows, and you can see the rest that are on the list here. Now, what you need to be aware of is which situations that you would use these in. So for example, a word processor you might use for a business document because you're able to change the spelling, you're able to look at the grammar, you're able to change the formatting of it, whereas desktop publishing you would use in a situation where you have to make a brochure or a newsletter or even a leaflet. Now you can argue that you can do the same with word processors and desktop publishing, but you need to make sure that you pick the right option when you're doing a contrast in the exam. Now, there are database management tools that allow us to store data and maintain it, and we're able to filter information and organize it in a structured way. We know about presentations and video editing because you've made videos in school before and you've had to deliver presentations. So you need to be aware of each of these and what situations you would use them in. Now, factors to consider in the exam. You need to be aware of speed of the program. So is it going to be efficient for the job? Whereas if you were doing something in, say, for example, Microsoft Word, it might take you a while to produce a newsletter because you're going to have to change all the formatting. Whereas in desktop publishing, things are a lot easier and smoother to move around, and it tends to speed up the process. Now you might want to think about cost, because some products such as Microsoft Word you have to pay for, whereas there are open source products, and we'll talk more about that in this presentation, which are free and available for you to use. You also need to think about hardware. So if you're given a situation in an exam where they list the hardware and list the requirements of the actual software, you might need to be able to match those up. So some programs use a lot more of your system resources than others, and some might use up your memory. So you might notice that one program requires 8 gigabytes of RAM, and another only requires 2. So you need to weigh up your options there and think about which one is going to cause you less problems. So what I got you to do in the lesson is actually think about applications that would work in each of these categories. And the idea of this was to actually get you to think about how you use those applications and to go out and see that there's more than one available. We talked about Microsoft Word being in a word processor, publisher and desktop publishing. There are games, there are web browsers such as Chrome, Edge, Safari. So we got to start thinking about this. In an exam situation, you may get asked a question such as, Joe wants to make a brochure advertising his business. He owns a hotel called Astra Hotel, and he's spoken to his friends and he wants to create a brochure. You're going to have to, for a question like this, examine each piece of software. So you want to start off by explaining what desktop publishing is used for, what is word processing used for, what is a presentation package used for, because you're going to get marks to show that you know each of these inside out. It's after this point you want to make sure you show the advantages and disadvantages, but you must make sure that you provide some context to it, because I've seen in many situations people can contrast these and explain what the difference is between a desktop publishing application and a Word application, but the problem is you don't relate it to the context of the question. So you must make sure you justify your recommendation at all times, and also watch your spelling and grammar, because that is how you're going to get the full 9 marks on a question like that. So, moving on, in the previous lesson we learned about a number of utilities, and I'm going to give you a quick recap here just to kind of get you remembering how they're used and talk about some key points that kind of cross over to a number of different exam specifications. So let's move on. So we had antivirus software. Antivirus software was in charge of actually maintaining or removing problems from your computer. So if you have a virus, it can generally remove it or quarantine it, but also it prevents you from getting any further harm, and it can also get updates. So any new viruses that come in, it can deal with them. You've got disk defrag, where it moves the files on the hard drive closer to each other so that there's less rotation needed on the actuator head on your computer system. So the hard drive has all the files that it needs next to each other, and we talked about how it's not good to use disk defrag on solid state drives because of their limited read and write. Compression files such as 7-zip, WinZip, WinRAR, which is in charge of actually reducing the amount of space that your files take up. File managers such as Windows Explorer. We also have firewalls which stop people from intruding into your network. We also have backup utilities. So the backup utilities would be used to make sure that a large number of files are archived so that you can go back to them later. Now, what we started discussing is how there is open source software and there is closed source software. They're two very different things, being that one is generally free and the other you usually have to pay for. Now, open source software is usually supplied with all its original code, and it allows you as a developer to actually edit it and modify it to suit your needs. And that's really good because it means that you can have a bespoke piece of software that allows you to fit your own needs. Now, you are able to alter the source code and you're able to change it to whatever you need. And if you want to alter it and redistribute it, you are allowed to, as long as it is still distributed as open source. So you can't suddenly take an open source piece of software and claim it as your own and say it is now closed source. So you need to bear that in mind. And operating systems such as Linux are usually a really good example of this, and it's mostly free of charge. Now, the idea of open source software is that it encourages mass development, and it means that people don't have to actually worry about updates as much, because everybody working on one piece of software making it better can be a good thing, and it promotes creativity and sharing. There are drawbacks to it in that people could be malicious when they're updating the open source or could put viruses in it, so you do need to be aware of that. Closed source software is software such as Microsoft Word, PowerPoint, Excel, Adobe, software that you generally pay for, and it comes pre-compiled, so you don't get to see any of the source code hidden underneath it, and it's not made available for you to see, and it is copyrighted. Now, this is also known as proprietary software, given that the company owns the software and they make money off it. There's no point in them making the source code available because otherwise it's going to be amended and they're not going to make money of it. So closed source software doesn't allow you to make those modifications. Problem is you don't get as much time on people updating it either. So what are the key differences here? Well, open source software is free or cheap at least, and you may have evaluation periods. Whereas closed software, you could argue having to pay for it can be costly for a business. So if you were relating it to a school or any situation, you could argue about the impact of cost. Now, open source software, the only problem with it is it usually lacks the professional polish, and the interface usually isn't as friendly as something that is closed, because they hire a lot of professionals to actually design the interface when it comes to a closed piece of software because they're making money off it. Now you can argue that it's a good thing that there are thousands of developers worldwide working on an open source piece of software, but that can also be a problem because there's more chance of somebody malicious messing about with it. Whereas in a closed source environment, they usually have restrictions and there's usually a lockdown so that people are there that are responsible. So with open source software, you can always make improvements and adjustments to it. But like I said before, closed source software is more secure. So that's a kind of rundown and a debate, and that's the sort of thing that you're going to need to show both sides to the story on in an exam situation. So here's a task that I would have got you to do in the lesson to actually find some open source and closed source software and compare the two. So if you've done that, you will have seen some of the examples here on the slide. You may have looked at Libra, looked up some freeware. So continue doing that so you just have a better idea. What you'd need to think about on this exam style question, it would be an essay type question, is you need to show a debate of both sides of the story. Now first, you need to show that you understand what open source software is. You need to understand what closed source software is. Explain the advantages, explain the disadvantages, then make sure that you relate it to a situation. Don't make the mistake of explaining what open source and closed software is and then forgetting to actually relate it to a situation. They might give you an exam question that talks about whether it's okay for a school to use open or closed source software, and you're going to need to show both sides to that story. So please be aware of that, and also be aware of your spelling and grammar in order to get the maximum marks. Now, the next thing we're going to talk about is translators, interpreters, compilers, and assemblers. They are the kind of building blocks to a program, if you like. Any program that you write, any of the source code, so if you're typing print hello world, it is needed to be put into machine code so that the computer can actually understand it. Now, the next slide I'm going to show you, I'm showing you for a reason that many people get confused between the two, and you need to make sure that you know the difference. So what I'm showing you here is not machine code. This is assembly code. This is the code that the processor uses before it actually converts it into the binary that you see. So this is an example of the translation that you would see on this slide here. Okay, so you can see what it was originally and what it becomes. So machine code is the ones and zeros, okay, and you need to be aware that different translators do different things, and the translator gets the program from its programming form into machine code so that it will run. Now the first one I'm going to talk to you about is the assembler. So this is responsible for using low-level language code such as assembly. Like you can see here on the screen, you've got our memory and you've got our instruction. And what happens is each line, so it's a one-to-one relationship, one at a time, each line is converted into machine code. So you can see here that it's only done the top line, which is in yellow. It's not done the other lines yet. It's sequential, so it goes one line at a time. Whereas other translators actually do the whole line. So I'll explain more about that in a moment. So the problem with assemblers is that they're not compatible across different computer systems. And the best way for me to describe that to you is to think about how certain computer systems have different architectures. So think about the Harvard and the von Neumann, okay? They're very different in how they're run. So I want you to think about if you're writing a program that's been written in assembly, okay? It's not going to just map onto another machine. Okay, have a look at this diagram below. You can see that the machine code for one machine is different to another. Think about how some machines have reduced instruction sets and some have complex instruction sets. So don't make the mistake of thinking that assembly can be used on any machine. So the next thing we talk about is compilers and interpreters, and they're very different things. These are responsible for converting high-level languages. So what you will learn to program in is Python, or if you're around the world and you're watching this, you may be using another language, okay? And this converts it into either object code or machine code. And it's very different in that it's not a kind of line by line. This allows you to do multiple lines. So this is a one-to-many relationship, and you can see here we have our single line of programming can convert into many lines of machine code, whereas previously you noticed with the assembler that it would only do the instruction line by line, whereas this can handle multiple instructions and convert it into many lines of machine code. So interpreters are different in that what they do is they take one line of high-level programming code, it is then converted and then it's ran, okay? It's converted directly straight into the machine code and then it's run. Now, they are useful when you're debugging the program because what it can do is it can start running the program immediately. So you can just run the program and then as soon as you get an error, the program will crash when it has an error, okay? But this requires the whole source code each time it needs to run. So you need to make sure you've still got the original source code in order for it to work, all right? This can be a bit of a problem because it means that the source code can run quite slowly. So if you've got a really long program, doing this process each time, interpreting it is going to take a lot of time. Whereas with the compiler, what this does is it takes so as you can see in this diagram here, it takes the whole program from the start to the finish, converts it into the object code, okay, and the errors happen before it compiles. So if you're using Python, you may have noticed before that your error message comes up when you are compiling it, okay? Once it's done, this creates the object code, and what it means is anybody with the compatible system can continue to run it. The good thing about it is that you don't need to have the original source code anymore to run the program because you can just distribute the object that has been made. And it runs a lot faster than interpreted because it doesn't have to run through every line of code. It's already produced the program that you need. The only problem is if you do an update on that program, what you're going to find is doing that update means you've got to have the original source code. Now, remember, object code and machine code are two very different things, and all you need to do is look at the previous slide to see the two examples. As we go on to do A-level, you will learn more about the difference between those. So I'd like to thank you for watching. I hope these notes are useful to you, and any questions, just approach me in lessons and we'll go through that. Thanks for watching. If you want to subscribe, there are more videos that will be added as we progress. Thank you for watching. As a little side note here, please take a moment to look at the differences between all of the interpreters and compilers. Look at the programming languages that might be used, such as C compiler or BASIC. Look at the difference between error handling and make sure that you're aware of these for an exam situation. See you soon.